Mastering Machine Learning Prep, your ultimate self-check overview. Ready to crack the code of machine learning? Let's break down those tricky concepts so you can ace your prep. First up, supervised versus unsupervised learning. Think of supervised as teaching with answers in hand. Unsupervised is like discovering patterns all on your own. In supervised learning, data comes labeled, like photos tagged with animal names. The model learns to map inputs to outputs, kind of like helping a kid learn by example. Unsupervised learning. No labels, just data. Imagine sorting a messy box of Lego bricks by shape or color. No instructions, just your brain finding order. Let's talk metrics: precision, recall, and F1 score. Precision asks, out of all positive guesses, how many were right? Recall checks, of all real positives, how many did we catch? F1 score? It's the perfect balance. It's basically the love child of precision and recall, keeping things fair in tricky situations. Here's where you gotta think. In cancer screening, recall is king. You want to catch every case, even if it means some false alarms. Spam filter. Precision rules. You don't want your important emails getting lost in the junk folder. What about hyperparameters? Think of them as your model's setup knobs you tweak before training to get the best results. For example, the learning rate in a neural network controls how fast it learns. In K-means clustering, K decides how many clusters you create. Now, CNN fans, understand the receptive field. It's the patch of the input each neuron sees. The bigger it gets deeper in the network, the more context the model captures. Padding? Think same means zero padding to keep image size steady, while valid means no padding, so the image shrinks after convolution. How do SVMs split classes? Picture drawing a line that keeps the biggest gap from data points of different groups. The C hyperparameter decides how strict or relaxed that line is. High C means the SVM tries not to misclassify anything, even if the line gets complicated. Low C lets it make some mistakes to keep the boundary simple. K means clustering finds groups by assigning points to the closest center, then recalculating until clusters stabilize. But picking K too low or high, you'll either merge distinct groups or split similar ones unnecessarily. Ever heard of random forest? It's like a jury, many decision trees voting together. This voting reduces errors and avoids overfitting compared to just one tree's opinion. In Q-learning, you observe your state, pick an action, get a reward, update your knowledge, and repeat. It's like learning through trial and error with feedback guiding you. States are your current situations, actions are choices you make, and rewards are your success signals. Keep tweaking and learning until you master the task. Changing hyperparameters like learning rate or tree depth affects your model's fit. Too simple. You'll underfit and miss patterns. Too complex. Overfitting will ruin your generalization. Ever seen a confusion matrix? It's your model's report card, with true positives, false negatives, and more showing how well it predicts. Precision sits right here, TP divided by all positive predictions. Recall lives here, TP over all actual positives. Knowing both tells you if your model's a hero or a zero. Beware accuracy's trap. With imbalanced data, you might get 95% accuracy just by always guessing the majority class, without actually learning a thing. Cancer screening. Prioritize recall to catch every case. Fraud detection. Precision matters, so you don't flood investigations with false alarms. Handling missing or noisy data. First, spot and remove unusable rows or columns. Then, fill gaps smartly and clean outliers to keep your model sharp and reliable. The ML workflow. It starts with your problem, then data, exploration, prep, model choice, training, evaluation, tuning, testing, and finally deployment with monitoring. Watch for pitfalls, unclear goals, bad data, overfitting, data leakage, and ignoring monitoring. One slip and your whole project could derail. Poor early choices like sloppy cleaning or wrong metrics? They can snowball, wasting time and building unreliable models you don't want to trust. Let's run a real-world example: spam email detection. Define the problem: spam or not spam. Collect data and prep it carefully before training your model. Explore the data, check for imbalances, clean and format it. Then pick the model, train it, and check how well it does on unseen emails. Tune those hyperparameters, test again, and once happy, deploy it to catch spam while monitoring for changes over time. And there you have it, a full prep guide to help you nail machine learning concepts, evaluation, and workflows. Feeling ready yet? Remember, practice makes perfect. Keep testing yourself with real problems and watch your skills skyrocket. Hit like if this helped clear things up and smash that follow for more bite-sized machine learning wisdom.